This resource is the fourth in a multi-part series that considers a number of topics in trigonometry. Part 1 looks at radians, defining this alternate method for measuring angles and providing methods for converting back and forth between degrees and radians. Part 2 focuses on right triangle trigonometry, looking at the 6 trigonometric ratios. It also looks at the identities that define the other ratios in terms of sine and cosine. Part 3 explores the connections between trigonometry and the Cartesian plane. Part 4 considers the inverse trigonometric functions, used for finding angles when the ratios are known. Thus far in our exploration of trigonometry, we always knew the angle, or could easily identify about which angle we were speaking. But what happens if we actually want to find the angle, if we know the lengths of the sides? That is exactly the point of inverse trigonometric functions. There are two common notations used for these inverse functions. Using sine as an example, the inverse trigonometric function for sine could either look like sine raised to the -1 of some value x, or it could look like arc sine of x. Either notation means we want to find the measure of an angle whose sine is x. There are buttons on all scientific or graphing calculators to compute the inverse trig functions. They usually require pressing the Shift for Casio calculators or second for Texas Instrument calculators button to access a secondary function for the button, however. Let's see some examples. If we want to find the inverse sine of 0.5, then our angle would be 30 degrees. The inverse tangent of -1, according to the calculator, is -45 degrees. And the inverse cosine of 0.6 is 53.13 degrees. But are these the only answers? Remember that trigonometric functions are periodic. This means that function values are repeated multiple times. So how could we find other values for the angle? There is an angle in each quadrant that behaves exactly like a first quadrant angle, which is an acute angle. The only difference is the function value may be positive or negative. The acute angle, called the reference angle, is actually the smallest angle between the terminal side of the angle and the x-axis. For each angle, we will call the angle when measured from the positive x-axis theta, and the corresponding reference angle theta prime. If we are in the second quadrant, which means our angle is between 90 and 180 degrees, theta prime equals 180 degrees minus theta. If we are in the third quadrant, with angle measures between 180 and 270 degrees, theta prime equals theta minus 180 degrees. If our angle is between 270 and 360 degrees, we are in the fourth quadrant. Theta prime equals 360 degrees minus theta. Suppose we want to find the reference angles for 115 degrees, 290 degrees, and 200 degrees. 115 degrees places us in the second quadrant. To find theta prime, we subtract our angle measure from 180 degrees. Theta prime equals 65 degrees. 290 degrees is in the fourth quadrant. We subtract our angle measure from 360 degrees to find the appropriate reference angle. Theta prime is therefore 70 degrees. 200 degrees places us in the third quadrant. Theta prime will therefore be our angle minus 180 degrees, or 20 degrees. Earlier, we said that the inverse sine of 0.5 is 30 degrees. We also recognized the periodic nature of sine. This meant that there would likely be other possible angles whose sine was positive 0.5. Recall that sine is also positive in the second quadrant. This means we need to find the second quadrant angle whose reference angle, theta, is 30 degrees. To find theta prime in the second quadrant, we subtract 180 degrees minus the 30 degrees that is our reference angle, and find that the inverse sine of 0.5 could also equal 150 degrees. We saw that the inverse tangent of -1 was negative 45 degrees, which is the same thing as positive 315 degrees. But tangent is also negative in the second quadrant, so we want the second quadrant angle whose reference angle is 45 degrees. To find this, we subtract 45 degrees from 180 degrees, and realize that the inverse tangent of -1 could equal 315 degrees or 135 degrees. The inverse cosine of 0.6 was 53.13 degrees. However, cosine is also positive in the fourth quadrant. We subtract the 53.13 from 360, so the inverse cosine of 0.6 could also equal 306.87 degrees. One word of advice. Actually, a few of them. Be careful using the calculator when finding the inverse trigonometric functions. If the amount you are taking the inverse trigonometric function of is positive, the calculator will only provide the first quadrant version of the angle. If the amount is negative, the calculator will give the answer as a negative acute angle for sine and tangent, and the second quadrant version of the angle for cosine. Make sure that the answer the calculator gives makes sense for your problem.